Hello everyone and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, data modeling. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data driven world. First question: what is a data model in Power BI and why is it important? A data model in Power BI is a structured way of organizing tables and defining how they connect through relationships. It helps Power BI understand how data from different tables should filter each other, ensuring accurate calculations and reports. A well designed model improves performance by reducing data duplication, unnecessary columns, and inefficient relationships. It provides a strong foundation for writing DAX formulas, as a clean model makes calculations simpler, faster, and more reliable. Second question: what are fact tables and dimension tables? Give examples. A fact table stores numeric and measurable values like sales amount, profit, quantity sold, represents business events or transactions, and acts as a central table by containing foreign keys that link to dimension tables. Example: a sales fact table includes date key, product key, quantity, and sales amount. A dimension table stores descriptive attributes like product details, customer information, or region, provides context for analyzing fact data, helps users slice and filter reports, and contains primary keys that uniquely identify each record. Example: a product dimension table includes product key, product name, category, and brand. Third question: what is grain in a fact table and why must it be defined clearly? Grain refers to the specific level of detail for each row in a fact table, such as one row per sale or one row per order line. It ensures that all calculations are accurate and consistent by defining how data should be aggregated. Clear grain prevents issues like duplicate counting, inflated sales, or inconsistent totals. It guides how dimensions are connected and how measures are built in DAX. Fourth question: what is normalization versus denormalization? Which is better for Power BI and why? Normalization is the process of splitting data into multiple related tables to eliminate redundancy and improve data integrity. It is ideal for transactional databases where updates and storage efficiency matter. Denormalization combines related tables into fewer, wider tables to simplify data access and reduce joins. Power BI generally performs better with denormalized structures, especially star schemas, because fewer joins lead to better query performance, faster refresh times, and simpler DAX logic. While normalized designs are cleaner for databases, denormalized models are more efficient for analytics. Fifth question: what is a semantic model in Power BI? A semantic model is a business friendly layer that represents logic, metrics, relationships, and definitions in a way that end users can easily understand. It abstracts technical data structures and provides standardized measures, KPIs, hierarchies, and role based views. This ensures that everyone in the organization uses the same definition of metrics like revenue, customer count, or conversion rate. By centralizing logic in the semantic layer, Power BE enables consistent reporting, reusable calculations, and simplified self-service analytics. Sixth question. How do you optimize a Power BI data model for performance? Remove unnecessary columns, rows, and entire tables to reduce data model size. Reduce high cardinality fields, such as splitting date time into date and time or removing unique text IDs. Follow a star schema structure, ensuring clear one-to-many relationships and single-direction filtering. Avoid bidirectional filtering unless absolutely necessary, as it can slow down DAX calculations and cause ambiguity. Seventh question. Practical. You receive a dataset with repeated values and redundancy. How will you convert it into a proper data model? Identify columns with repeating descriptive values, e.g., product name, category, and move them into separate dimension tables. Remove duplicates in these new dimensions and assign primary keys to each record. Convert the remaining transactional data into a fact table with foreign keys pointing to dimensions. Build relationships in Power BI to form a clean star schema, improving performance and ensuring accurate reporting. Eighth question. What are relationships in Power BI and how do you create them? Relationships define how tables are connected and how filters propagate between them. They allow Power BI to combine data from multiple tables using primary key foreign key logic. You can create relationships automatically, auto-detect, manually in the model view, or through managed relationships. Correct relationships ensure accurate DAX calculations, correct totals, and consistent filter behavior across visuals. Ninth question. What is single direction of a relationship? A single direction relationship means the filter flows only in one direction, most commonly from a dimension table to a fact table. It is used to create a clean, controlled, and predictable filtering path in a star schema. This direction ensures that calculations remain accurate because only one table influences the other, reducing the chances of circular filtering or ambiguous logic. You should use single direction relationships in almost all standard data models, especially star schemas, where dimensions are meant to slice and filter facts. It provides better performance, simpler DAX behavior, and a more stable model. 10th question. What is bidirectional of a relationship? A bidirectional relationship allows filters to flow both ways between two tables, enabling cross-filtering and more flexible interactions across the model. It is used when multiple tables need to filter each other, for example, in scenarios involving many-to-many relationships, disconnected dimensions, or when a fact table must propagate filters back to a dimension. However, this relationship type must be applied cautiously because it can easily introduce ambiguity, circular filtering paths, and incorrect totals in DAX. You should use bidirectional filtering only when a business requirement truly demands cross-filtering and when the model cannot function correctly with single direction filters. 11th question. What is a composite key? Does Power BI support it? A composite key is a key formed by combining two or more columns to uniquely identify a row, e.g., store ID plus date plus product ID. Power BI does not support composite keys directly for relationships. To handle them, you must create a surrogate key by merging columns using Power Query or DAX. Surrogate keys simplify relationships and improve model clarity. 12th question. How do relationships affect DAX calculations? DAX calculations depend heavily on filter propagation from related tables. Incorrect relationships lead to wrong results. A proper relationship ensures that dimensions correctly filter facts, enabling accurate sum, count, and calculate expressions. Relationship direction affects how calculate modifies the filter context. Inactive or incorrect relationships may cause visuals to ignore filters, showing misleading totals. 13th question. What happens when incorrect relationships are created? Incorrect relationships can cause wrong totals or duplicated values because filters propagate in unexpected or unintended ways. They may create ambiguous or circular relationship paths, which can lead Power BI to throw errors or disable certain relationships. DAX measures may fail, return inconsistent results, or ignore filters due to improper filter flow. Overall performance can degrade as Power BI struggles to resolve complex, conflicting, or unnecessary filtering paths. 14th question. Practical. You get an ambiguous relationship error. How will you fix it? Remove or modify bidirectional filters that are causing circular dependencies and set them to single direction where possible. Introduce a bridge table to resolve many-to-many scenarios and eliminate duplicate filtering paths. Convert problematic relationships into single-direction relationships to create a simpler, more predictable filter flow. Verify that dimension tables contain unique keys to prevent accidental many-to-many relationships that contribute to ambiguity. 15th question. What is cardinality? Explain one-to-one, one-to-many, and many-to-many. Cardinality defines the type of relationship between two tables based on how their keys match one-to-one, one-to-one. Each key in table A appears only once and matches with only one key in table B. One-to-many, one-to-star. A single value in the dimension table links to multiple rows in the fact table. Example, one product, many sales. Many-to-many. Both tables contain repeated values in the relationship column. Example, a customer belongs to multiple segments and each segment contains multiple customers. 16th question. Why is one-to-many the most common cardinality in Power BI? Most data models follow star schema with one central fact table and multiple dimension tables. Facts contain repetitive IDs, e.g., product ID repeats for every sale. Dimensions contain unique IDs, ideal for filtering facts. Power BI's filtering works best when dimensions filter down to facts, which requires one-to-one relationships, ensures performance, optimized storage, and accurate aggregations. 17th question. What challenges occur with many-to-many relationships? Ambiguous filtering. Power BI doesn't know which table should filter the other. Double counting or incorrect totals during DAX calculations. Circular dependencies may occur when multiple relationships interact. Performance issues when large tables contain duplicates. Harder to maintain clean schema and interpret reports. 18th question. How do bridge tables resolve many-to-many problems? A bridge table is an intermediate table containing unique keys shared by both original tables to resolve many-to-many relationships. It converts the relationship into two one-to-many, one-to-star relationships, ensuring filters propagate clearly and unambiguously. Using a bridge table prevents duplicate records, eliminates ambiguity, and ensures accurate aggregations. DAX calculations become more predictable and reliable because the filter context flows properly through the bridge table. 19th question. Practical, sales table and product table both have duplicate product IDs. How do you fix the many-to-many relationship? Create a product dimension, dim product, extract unique product IDs, remove duplicates, and include attributes like product name, category, or brand. Connect dim product, product table, and dim product. Sales table using one-to-many, one-to-star relationships to remove direct M-links. If duplicates persist or attributes are spread across multiple tables, create a bridge product ID table containing unique product IDs and connect sales arrow bridge arrow product. The final model eliminates many-to-many relationships, creates a clean star schema, and ensures accurate filtering and aggregations in visuals. 20th question. What is a star schema? A star schema is a denormalized data model with a central fact table connected to multiple dimension tables. Dimension tables contain descriptive attributes used for filtering, slicing, and analyzing the fact table. It provides simple, clear relationships, typically one-to-many, making DAX calculations predictable and fast. Star schema is widely used in Power BI because it improves performance, simplifies reporting, and reduces complex joins. 21st question. What is a snowflake schema? A snowflake schema is a normalized data model where dimension tables are split into multiple related tables. It reduces redundancy and saves storage by storing shared attributes in separate tables. Relationships become more complex, often requiring multiple joins between fact and dimension tables. Snowflake schema is less common in Power BI due to slower performance and increased DAX complexity. 22nd question. Why is star schema preferred in Power BI? Star schema is preferred because it provides simple and predictable relationships between fact and dimension tables, making the model easier to understand. It reduces the number of joins required in queries, which improves report performance and refresh speed. Filter propagation is straightforward, ensuring that DAX calculations return accurate and consistent results. Star schema is also easier to maintain and allows end users to analyze data without needing deep technical knowledge of the model. 23rd question. How does schema design affect DAX performance? A well-designed schema, like a star schema, improves DAX performance by reducing the number of joins and simplifying filter propagation. Complex snowflake schemas with multiple normalized tables can slow down calculations because DAX must traverse more relationships. Proper schema design prevents ambiguous filter paths and ensures that measures are calculated correctly across all visuals. Optimized schemas also reduce memory usage and improve the speed of report, refreshes, and interactivity. 24th question. How does schema impact evaluation contexts? In a star schema, the filter context flows predictably from dimension tables to fact tables, which ensures reliable DAX measure calculations. Snowflake or poorly designed schemas can create complex filter propagation, which may lead to incorrect totals or duplicate values. Ambiguous relationships or circular dependencies in the schema can disrupt evaluation context and produce misleading results. A clean schema ensures that each visual in a report has a consistent row and filter context, supporting accurate insights. 25th question. Practical. You have several normalized tables. How will you design a proper star schema? Identify fact tables containing numeric, transactional, or measurable data and dimension tables with descriptive attributes. Consolidate related attributes from multiple normalized tables into single dimension tables to reduce complexity. Connect dimension tables to the fact table using one-to-many, one-to-star relationships to create a clean star schema. Ensure each dimension table has unique keys, and fact tables reference these keys correctly, enabling accurate and efficient DAX calculations. 26th question. What is an active relationship in Power BI? An active relationship is the default relationship used by Power BI for filtering and calculations between two tables. It determines how filter context flows from one table to another during DAX evaluations. Only one active relationship can exist between any two tables at a time, ensuring clarity in data propagation. Active relationships are automatically applied in visuals and calculations unless explicitly overridden using functions like user relationship. 27th question. What is an inactive relationship? An inactive relationship exists in the model but does not affect filter propagation or DAX calculations by default. It can be activated temporarily using DAX functions such as USERELATIONSHIP for specific calculations. Inactive relationships are useful for modeling scenarios like role-playing dimensions, e.g., when a fact table has multiple dates like order date and ship date. They help maintain multiple potential relationships without causing ambiguity in the default model. 28th question. Why does Power BI allow only one active relationship between tables? Allowing only one active relationship avoids ambiguity in filter propagation and ensures predictable DAX calculations. Multiple active relationships could create circular filtering paths, which can lead to errors or double counting. It simplifies model design, making it easier to maintain and understand for end users. Other relationships can remain inactive and be used selectively in calculations to handle special scenarios. 29th question. How can you activate an inactive relationship in DAX? Inactive relationships can be activated temporarily using the user relationship function within a DAX measure. This function allows a specific calculation to use the inactive relationship without changing the default filter flow. It is commonly used when a fact table has multiple related fields, such as calculating sales by ship date instead of order date. Using this method keeps the model flexible while preventing ambiguity in standard reports and visuals. 30th question. When should you intentionally use inactive relationships? Inactive relationships are useful when a table has multiple potential relationships to a fact table, like multiple date fields or alternative lookup keys. They help manage role-playing dimensions, allowing different perspectives of the same data without breaking the model. Inactive relationships prevent ambiguity in filter propagation while keeping the model clean and maintainable. They should be used selectively in DAX calculations only when specific measures require them. 31st question. Practical. You have order date and ship date in the same fact table. How do you model them? Create two separate relationships from a date dimension to the fact table, one for order date active and one for ship date inactive. Use the inactive relationship in calculations by applying user relationship in DAX measures. This allows reporting on both order and shipment timelines without ambiguity in filters. The final model remains clear, avoids circular dependencies, and supports accurate aggregation for both date contexts. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.